Hi everyone, my name is Thomas Kim. Today is July 4th, or 4th of July 2021. This is my 11th episode about modern C++ experiments. In this episode, we will do experiment on align S. Then we will learn the smarter thread launcher std jthread or join thread. For more information about std jthread or join thread, please double-click this link. std jthread is introduced to C++ 20 standard. The class jthread represents a single thread of execution. It has the same general behavior as std thread, except that jthread automatically rejoins on destruction and can be cancelled, stopped in certain situations. So, using a std join thread is much simpler than using a std thread. Without further ado, let's get started. Start Visual Studio Code, open your working folder, create a folder 011 align as. Click this button, align as .cpp, create another file, click this button, jthread.cpp, hit enter. I will close all files, Ctrl V. We are in the file align as .cpp. Include talkplayfun output HPP. We will be using thread talkplayfun sstring string const auto and talkplayfun and void test compiler aligned int a int b auto dist a b. We take address of a minus address of b, stream distance between a and b. We will typecast long dist a b, and then we will take std abs. We want to make the distance a positive number. Int main, we call this function here. I will put another message, bytes. I will put a carriage return. Now in the command prompt, clexc sed C++20 align as .cpp fe n.exe, hit enter. clsm. We subtracted the address of B from the address of A. The result is 1 byte. This is wrong calculation. We have to typecast character pointer. This typecasting is important. We build again clsm. So distance between A and B is 4 byte. It makes sense. Don't forget typecasting to character or unsigned character. Now I copy this, paste, test custom aligned. Now we give align as. We use multiple of 2. For example, 16. Okay? We should give this number multiple of 2 or power of 2. Then I copy this, paste it here. I will put string and there. We build again CLSM. So distance between A and B 16 bytes. 16 bytes. Or we can remove this alignas. We try again. M. The result is the same. Here is my warning. Do not use align as or custom memory layout. Let C++ compiler align the memory layout of the variables, because 99 times out of 100 cases, the C++ compiler is outsmarter than most of us. However, we need alignas, especially when we use multiple threads accessing the members of a class simultaneously in cache line friendly manner. I will not discuss cache line friendly. Instead, stream STD hardware destructive. Stream STD hardware constructive. Here, cache line destructive. Copy this, paste it here, cache line constructive. These two compile time constants are introduced in C++20. I will put one more in there. Now, CLS, we build again. CLSM. Cache line destructive, 64 bytes. Cache line constructive, 64 bytes. Now, copy this. We can put here. We build again. It should be SED. We fixed CLSM. Now, distance between A and B. Distance between A and B is 64 bytes. Cache line friendly. When we use multiple discrete CPU core. I will discuss cache line friendly in near future. Now let's move on. We will discuss multi-threading. When I say do not use low-level multi-threading, I do not mean you don't need to learn low-level multi-threading. Without solid understanding of the low-level multi-threading facilities, we cannot use properly and correctly high-level threading libraries. I say high-level parallel multi-threading libraries such as C++ standards parallel algorithm, Intel TBB, SQL, OpenCL, Vulkan, etc. Without solid understanding of low-level threading facilities, we cannot use properly and correctly high-level parallel multi-threading libraries. Now, STD, atomic, long data we initialize with 10. A single instance of atomic long initialized with 10. STD array long we will create 5 elements. Return values 5 elements of long all initialized to 0. Void walk function in thread num long while from this atomic data we patch the previous value, then increment. We will use std memory order. std memory order we will use relaxed. I will discuss memory order in near future, so please don't skip my future videos. This container index is thread num. We assign file void to test jthread for the first time. I create a block std jthread thread 0. We pass this work function. Please note that this work function takes an argument thread num. So this is first thread or 0th thread. Copy this here. 1, 2, 3, 4. So 5 thread. 1, 2, 3, 4. This block is important. This block is important because the destructor of std jthread waits until its work function. In this case, this work function terminates. Now here stream we can display the return values. Now we call this function, paste it here. I will disable. In the command prompt cls we build again cls m. So using multiple thread 0 up to thread 4, we initialized this return value array in parallel with this simple code like this.